This tutorial is going to talk about section 4.1 over congruent figures. And the first thing that we need to talk about is actually how to name congruent figures. So in order to actually be congruent figures, the figures have to have every single side congruent as well as every single angle congruent. So I want you to take a look at this statement over here to the right that says triangle TDJ is congruent to triangle FRC. So let's say I wanted to put tick marks because me personally, I'm a visual learner, and I like using tick marks to let me know which sides are congruent to what. So I want you to take a look at the order upon which this is written. So TD is this segment right here. And the way that this congruent statement is written is in the order of what sides are congruent to what. So that means TD is going to be congruent to FR. So I'm going to give FR one tick mark as well. And then I'm going to try to stay in blue. Okay. So then what about the next one? Well, DJ, okay, so I'm going to give that two tick marks, is going to be congruent to RC. So RC is going to get two tick marks. And then lastly, I'm going to have J, and then you go back to the beginning, JT, or I'm sorry, JT, so that's 1, 2, 3, and then CF. Now, the same thing goes with the angle measures. So just in order, this means angle T right here is congruent to angle F. So angle T congruent to angle F. So one arc mark. And then angle D is congruent to angle R. And angle J is congruent to angle C. So everything in a congruent statement, that's what this is right here. This is a congruent statement. Should tell you all the sides that are congruent as well as the angles. So what I would say then is I would list out all the parts that are congruent. So for example, I could say TD, and this is a segment, is congruent to, and it has to be in the same order, so FR. Or if I wanted to name angles, let's take angle J for example. So I could say angle J is congruent to angle C. So those are some ways in which you can name your congruent figures. So let's take a look at this example. This is example 3 on page 199, and it gives this figure. And the question is simply asking if these two triangles are congruent. So in order to have congruent figures, remember all of the sides and their corresponding sides need to be congruent, as well as all of the corresponding angles. Okay, now corresponding just means, like in the previous example, that the angle with one arc mark would be corresponding to the other angle with one arc mark, and so on and so forth. So let's take a look at this picture and see what we got. I'm going to try to list out all the sides that I know. So I know that side AB, let's see if we can determine if that's congruent to anything in the other triangle. And it does look like it is the corresponding part of the other triangle. We'll just have to make sure that we name it in the same way. So if I look at AB, that means I measured it from this part, this one arc mark, to the right angle. So I want to name it in the same exact way. So up here I'm going to label it from E to D. So there we go, is E to D. And I also know that side AC, this hypotenuse of this one triangle, is congruent to this side right here. But how do I name it? Well, I went from the one arc mark to the center, so that means I'm going to name it EC. And then the other segment, the one that's resembled with a 4, I'm going to say that segment BC is congruent to, let's see, so that's from the right angle to the center, so DC. So just by looking at this picture alone, I can determine all 3 pairs of my sides are congruent. Now we need to check for the angles. So I know that angle A is going to be congruent to angle E because they have the same amount of arc marks. So that's nice. I also know that angle B is congruent to angle D because they're both right angles, and all right angles are congruent to each other. But we run into a problem at C because we can't just say that it's angle C. We've got 2 different angle C's here. But how would I be able to determine if this angle here is the same as this? And you should be thinking maybe vertical angles, because that's what those are, and vertical angles are always congruent. But this time I have to be pretty careful about how I name this. So I'm going to use a different color. I'm going to use purple, and I'm just going to start by letter B, and I'm going to name this angle BCA instead. So angle BCA. I have to give it a 3-letter name because I've got 2 angle C's. So I started from the right angle, I went to the center, so over here would be D, C, and then E. So I was able to prove all 3 pairs of my sides and my angles are congruent, so the answer to this question is yes, they are congruent, and all of this stuff right here is my proof as to why. And if you wanted to extend this, you could even say this reason because of vertical angles. Another kind of problem that we're going to run into is being given a picture with all of its labels, or at least some, and asking you to conclude if the figures are congruent. So just like before, we want to determine if all of my pairs of sides and angles are congruent. And I think it might be easier to tackle the angle part first. So I know that angle R is congruent to angle U, okay, because they have the same amount of arc marks. And I know that angle RTK, I'm going to highlight that in blue so you can see it, RTK is going to be congruent to angle UTK. So that's good, but then what about this pair of angles at the bottom where K is? Well, you have a theorem in your textbook that is going to help us with this. It's theorem 4-1, and what it says is that if I have 2 triangles like this, and 2 of the pairs are congruent, then the third angles must be congruent. So because of that theorem, I can now list that I've got 2 more angles that are congruent. So I'm going to say RKT, so angle RKT is congruent to angle UKT. So far I've got all 3 pairs of my angles and we're good to go. Now let's do the sides. So segment RT has 1 tick mark, so that's going to be congruent to segment UT. And I also know that RK is congruent to UK, and that's pretty self-explanatory. But what about this piece, the piece they share together? And this is a little kind of tricky technique that you have to use. If I were to pull these two triangles apart, so I want you to envision you taking each of those pieces as they are and pulling them apart in your head. TK would be present on both of those triangles, and it would be congruent to itself because it's the same segment. So this segment we can use, it is congruent to itself by the reflexive property. So that's how I know I can use that. So I can simply say TK is congruent to TK. And if you want to list the reason, and I strongly suggest you do so you know what you're doing, is your reason would be the reflexive property. So are these figures congruent? Yes, they are, because I was able to determine all of this information just by using my theorems and postulates. And that's it. That concludes this tutorial.